In this video, I'll be talking about median and mode. Median is the middle number in a set of ordered data. It can give a good description of numerical data, even if there are outliers. The mode is a data item or data items that appear the most often. A data set may have more than one mode or no mode at all. Mode is often useful when the data items are repeated or not numerical at all. So if you were asking people what are their favorite types of pizza, so you got, cheese, 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 pepperoni, pepperoni, vegetarian, cheese, cheese, vegetarian, pepperoni, beef. Since that's not numerical, mode is appropriate there because cheese was the most often said pizza item. All right, so let's take a look at a set of number data here. We have 9, 25, 7, 13, 4. If we wanted to find the median of this set of data, the first thing we'd have to do is put it in order. Okay, it has to be ordered. So let's go low to high here. We go 4, 7, 9, 13, 25. And then what I'll do is I'll just cross out the ends until I get to the middle. So 4 and 25, 7 and 13, median is 9. All right, let's take a look at another example. So here's if a scientist were going to a river to count fish, and every time he went to the river, these are the different counts he got of fish, and we want to find the median of this. First of all, we'd want to put it in order. So looks like we have an 18. So when we have this much data, it's good to be organized as we're putting things in order. I see that 18 is the lowest. As soon as I use it, I'm going to cross it out. Then I have a 19. I think I had two of those. So I'm going to write 19, 19. I see a 20. I see another 20. So 20, 20. Then see 22. So I see a 22. Two 23s. A 24. And a 34. What I'll also do to make sure I didn't miss anything, which is a pretty common mistake in these types of problems, is I'll recount my data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 pieces of data. So now I'm feeling confident that I have it all, and it's in order. So now I'm going to start crossing out the ends. I know there's definitely more than 3 pieces of data, so I'm going to cross out 2 at a time. So 2 on the end there, 2 on this end. Okay, now I'm left with 2, which is different. In the previous example, I had an odd amount of data, so that middle number was a 9. Now, when there's an even amount of data, there's going to be 2 numbers in the middle. So what you do is you take the average of those 2 numbers. Okay, in this case, it's pretty easy. The average of 20 and 22 is in the middle there, 21. But if you didn't know to do that, you just add the 2 numbers, 20 plus 22, and divide by 2. So 42 divided by 2 equals 21. So the median in this case is 21. All right, let's go on to another problem here. Let's say we did some research and we were trying to decide how long people spend on the internet. And here is some times that we got in minutes. So we got 50, 276, 57, 50, 62, 53, 72, 71, 63, 60, and 22. So the question here is the mean, median, or mode the best descriptor of the data? So we're going to need to figure out all these things here. So we might as well start with the mean since that's the first thing. So we're going to need to add up all this data. So we have a 50, we have a 276, 57, 50. So it's really important to keep it lined up here. 62. You know what I'm going to do? I'm going to stop at 62. I'm going to add it up just because when my list gets really long, I'm bound to make a mistake. So I'm just going to start here. So 7 plus 6, that's 13, that's 15. Okay, carry the 1, so 6, 13, 18, 23, 29, 9, 2. So 495 so far. That's up to here. And then we have a 53, a 72, a 71, a 63, a 60, and a 22. All right. So 5, 6, 7, 8, 9, 10, 11. And then 6, 13, 20, 26, 32, 34. So now I'm going to combine these two lists. So 495 plus 341. We got 6, 13, and 8. So why don't you pause the video, take time, do that addition yourself, see if you get the same answer, and then also finish the average by doing the division, and then when you resume, we can see if we got the same answer. So I'm at 836. Let's slide some of these calculations out of the way here. Oops, missed some of it. 495. I got a 1 over here somewhere. All right, and let's move all that over. All right, so we have 836, and we're going to divide that by how many pieces of data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces now. 11 goes into 83 7 times. Got 6 left over. All right, so 76 is our average. So I'll write that down. Mean equals 76. Now I'm going to need to order the data, and I might as well do that down here on the bottom. So my lowest looks like a 22. I'm going to change color so I don't get confused here. 22. Got that one, and then I got a 53. I got a 50. Two 50s. Got a 57. So 53, 57. Got a 60, 62. I got a 63. Now we got a 71, 72. And finally a 276. Now let's find the median here. So I'm going to cross out a couple on the bottom, a couple on the top. Cross out a couple more on the bottom, a couple more on the top. Cross out one, and looks like 60 is the median. So I'm going to write that here, median 60. And then the mode, let's see, I had two 50s, and that's it. So the mode was 50. So now going back to the question, best descriptor. Well, the median 60 looks like it's pretty close to all the data. We got some 50s, a bunch of 60s, some 70s. Then we got some outliers here. We got a 22, which is decently far off comparatively. Then we got this 276, which is quite a bit off. So I consider those outliers and the 276 mostly. And we can see how that affects the mean. It's quite a bit higher than the median. The mode, I would say, is not a good descriptor just because the mode happens at the lowest point or one of the lowest points of the data. So I'm going to say no. And I would say the median is best because of this outlier here is throwing the mean up too high. Notice the mean, the average, would actually be higher than every other number in this list except for 276. And that's not really a good sign for the mean to have. So I would say median is the best descriptor here. All right, thanks for watching.